Mate 1. We are online dating based here in Montreal. And of course, we are hiring, but more about that afterwards. I'm going to speak to you today for around 15-20 minutes. It's going to be fast, but hopefully you'll all be focused. You'll know everything I'm talking about, so it's going to be simple. I'm going to discuss with you something called mypipe, which is an application that we've been working with for a while now. It's evolved over time. mypipe is kind of like the third iteration of this application. It's been used for buffering and consuming MySQL changes via Katka. So, real quick overview. Who's this guy? Quick Mate 1 intro, motivation, features, design architecture for the project, practical applications and usages, followed by a very nice system diagram to show you everything. And then if you have questions and answers, you can do them here, you can do them after, it doesn't matter. So first, real quick, who is this guy? I've been using Linux and OpenBSD as a developer since around 1996. And I started out with C, that's what you were taught in school. And then I started looking at Ruby because I wanted more dynamic stuff. I was working with the web a little bit as well. I moved to Montreal in 2007, and that's when I started using the JVM. Java for me at school was like something, I don't want to look at Java. I was a C guy, what the hell is this virtual machine, memory management? I don't want that. But then, got into the web more, got into JVM more, and started to see that there's more to it than what you learn at school that you don't really like very much. So lately, I've been working with distributed systems, mainly doing Scala, and lately it's kind of like since 2010-ish, using all these technologies and basically doing that. So quick intro, we're online dating, we've been around since 2003, based here in Montreal. Started with like 3 people, we're around 30 right now. The engineering team is around 12 geeks and geekettes. We're always looking for talent, always hiring. And also we run our own hardware, we have our own colocation facility, so that gives us like another thing also to play with, not just the software, but also the actual infrastructure. Oh yeah, of course, github.com/mate1, all of our open source stuff is there. So mypipe, very quick feature overview. What are we talking about here? What is it thinking? First of all, you guys familiar with MySQL? Oh, yes, great. MySQL binlog replication. You guys also have an idea about what's going on there? Great, okay. So, what does, no? Yes? I'm not seeing the same word here. Okay, so, there, last one. So, I'll explain a little bit about replication, and you'll see how it kind of all fits into this. So basically, when you have MySQL master and you write data to it, you want to be able to take these changes somewhere, replicate them somewhere else. Either because you want to read your read from somewhere else, or because you want to like have some kind of redundancy on the DB. So MySQL offers this through something called binary logs, and it allows you to basically take every change that has happened on the server and be able to then apply it to your slaves downstream. So what mypipe does is it comes in and it pretends that it's like this MySQL slave, and it emulates MySQL slave by reading the binary log. So very simply, all it does is it takes these events and it writes them to Katka. So in theory, very simple. What does it use in order to encode this data, and how does it store it? How does it move it around the network? It uses Avro to serialize and deserialize the data. And it can do it in 2 ways. It can either do it in a generic fashion, or it can do it in a specific fashion. So generically means it doesn't really know what kind of columns you have, what your database structure is, what the table looks like. It just knows that there's columns, keys, and values coming in. And it just blindly takes these keys and values and pushes them down the track. If you have a specific schema, so you have, let's say, a user table, and you know what your fields are, and you want to be able to keep that schema all the way within Katka, and then when you consume it, you want to be able to know the exact fields, and you want to be able to have like some kind of schema evolution, as we've been saying in the talks before. You want to use a specific way of encoding your data. So, mypipe is modular by design, and that was one of the biggest intentions in building it. Everything that it does can be done into different bits and pieces. So for example, as you know, a system like this, we need to save state. We need to be able to resume from where we left off in case something happens, in case something crashes. So we can do that through files. We can save our progress into the MySQL DB that we're actually reading from in case that DB rolls back or something happens. Our state is also in there and it follows it. We can even store these things in Zookeeper if you wanted to. We don't, but the implementation is out there, or anything else that you want to. Error handling is also modular. So if you have mypipe and you have business-specific logic that you want to execute whenever something fails or whenever something doesn't go exactly the way you want to, you can write your own plugins, put them in there, and handle all the types of errors that are in the system. Event filtering as well. You've got a stream of data. You don't always want everything in there. You want to maybe potentially pick and choose, or you want to route it slightly differently. You can also write a Scala module and plug it into mypipe, and it just does the logic that you guys want to. And last but not least, connection sources. So basically, where are the DBs living? How do I get my configuration? Do I read it like from a local file, or do I go to some config repository and get all of this stuff? Second part of the feature overview. We in mypipe can handle transactions, and we can handle alter tables. And that's extremely important, because obviously, when you're making writes with your DB, you want to know what rows are being changed altogether, so that you can take these changes and potentially apply them in a transactional fashion downstream on your other stores, or process them in a transactional fashion if you're just doing event processing downstream. And you want to know when tables are altered, obviously, because if the data changes, if you have new columns, if you have columns that are being dropped, you want to be able to know that, so that you can react to that accordingly. And you want to be able to refresh your schemas at the same time to deal with that. mypipe obviously can publish to any downstream system, but right now the main implementation is for Kafka. Initially, when we first started writing the mypipe, it was actually to just take the MySQL bin log and just pump it into Cassandra, so that you can do stats in Cassandra and be able to analyze all of the changes in MySQL. But then we were like, why do it this way? Buffer into Katka, provide a way for consumers to read this data and do whatever they want with it. And like Cassandra is just one thing, but you can have multiple types of downstream systems. Another really cool feature here, and I'll explain a little bit, is that it can bootstrap a MySQL table into Katka. So what that means is, if you've got a table in MySQL that's been receiving data for a while, and you want some downstream system to be able to go through the entire data stream, or the entire data set that's in this table, and then start to consume new events and updates as they come in, mypipe can do that for you. So what it does is basically, it can, very simply, issue selects from a table, transform these selects into events that represent or are similar to MySQL bin log events, pump them into Kafka again, so you've got the entire history of your table with all the users, and then latches onto the binary log to continue updating your data as it's flowing downstream. So this lets you just, if you're not starting now, and you've already started before, you have systems that are already running, you can plug mypipe in, bootstrap your downstream system from that, and continue processing data. Obviously, it's super configurable. You can configure the Kafka auth names whichever way you want to. You can whitelist and blacklist certain tables. Maybe you don't want everything. Maybe you want some kind of format where the topic in Kafka is basically called something like the DB name and then the table name and then something else. You can configure all of those things yourself. And last but not least, extremely important, comes with a console consumer who doesn't want to see what's in Kafka and wants to be able to decode it easily. Slightly different than the default console consumer, because it has to interact with mypipe schema repository so it can decode all the algorithms. And last but not least, also Dockerized development and testing environment. Working on this system has become so much easier ever since we plugged Docker into it, simply because, from the talks before, you can run everything without having to install a single dependency. Everything's running inside the Docker. You don't have to really pay for anything much. And it's just a lot smoother. You don't have to maintain dependencies on the system again. You don't have to worry about all of that. And it's very accessible for anyone. You just download it, you can run it, and you can just see mypipe working on your laptop right there, doing the actual thing with MySQL, with Katka, everything. So I just want to give you a little bit of information about how it works internally and how it processes these events and how it deals with them. So obviously we have something which is called the binary log consumer. It maintains connections to the MySQL database. That's its main point. And then it handles certain events that are coming in. Specifically, the interesting events are like the table map event. And this is MySQL specific. I'll explain what they are. Query events, XID events, and finally, what we're interested in are mutations. So the table map event is basically an event that gives you table information every time the binary log is sending some kind of event to you. And the reason that happens is because MySQL binary log protocol is trying to be efficient, and they do not want to encode all the row names and the types and all this information within the stream. So when you basically get any event from MySQL, all you have is a table ID, and that's it. So you cannot really determine what's going on. You need to take this table ID, and then you need to figure out what the table is, and then you have to be able to map the data coming in with the structure that you have in the DB. So this is the table map event. It's extremely important because without it we don't know any structures. But we have to handle it every single time. Then we have queries like begin, commit, rollback, alter. I think these are pretty self-explanatory. Extremely important also to be able to see transactional boundaries and alter table events so that we can keep our schemas up to date as the DB is changing. And also, it basically provides like an enriched binary log API. So like I said, anyone right now can go and you can download the Java library and you can start consuming the binary log API like this. The libraries are out there. I use them for mypipe, and they're really pretty simple and very powerful to use. The main thing is that they're very raw, and that's why here, like we provide an enriched API, which does all of these lookups for you, and it gives you finally Scala case classes that are representative of everything. So when you have essentially like a certain, let's say you have a user table and a user has been changed, you will get that user, you will get all the fields that have changed, you will get the previous values, the current values, you'll get the table that it relates to, whether it's part of a transaction or not, and all the information you need in order to be able to process this row properly without having to go and like, gather it yourself. So yeah, I mentioned that it's all driven through case classes. It's Scala friendly. I'm trying as much as possible, we try to like make it option driven, avoid the annoying things like using nulls. Unfortunately, we're speaking with Java libraries, so we have to like hide that in certain places. But we're trying to do it the best that we can. Obviously, it's a work in progress. There will still be the occasional null here that you grab through the source code. So the table map, having explained that to you, I want to tell you actually how it works on the inside. When you see a table map event, the system has to be able to process this immediately. And at the same time, it has to be able to process them in some kind of serial or linear fashion. Because there's no point in getting multiple events and trying to work with them if you haven't handled that table map first. So the way that table maps are handled are basically through something called the MySQL metadata manager. This is Akka, and it uses Akka mainly just to give one actor per database. And in this case, we're not really using Akka for concurrency. We want to use Akka here just to have this actor queuing certain events for us and to be able to have one actor respond to one type of query. So the way that it works is using something in MySQL called the information schema. I don't know if you guys know it. I'm sure a lot of you do. And the idea of the information schema is that it holds every single interesting bit of information about a table within MySQL. So we receive a table map event, we go, we query the database through this actor, we get all the information back, we build a local cache so that we don't have to keep doing this. But this cache is smart and it's possible if it needs to, for example, when tables are altered. And then we basically just hand this information back. And that's how we join it and we enrich the events that are coming into the system and forward. I want to show you a little bit the Katka message format. So basically, we've got an event from MySQL, hold it. We have looked up this events tables and metadata and everything, and we've decoded it and it's all good. And then we've encoded it back into Avro. So now we can pump it across the network or somewhere else. So it has to go into Kafka. So how does it look in Kafka? If you consume this series of bytes, it's byte array from Kafka, what will it look like? Pretty simple, really. The first byte is just a magic byte. And basically, it's like a protocol indicator or verb. And then the second byte is a mutation type. So what's a mutation type? You have three types of mutations. It can be an insert, it can be an update, it can be a delete. So it mutates the system. So one byte to represent that type. After that, we have a schema ID. If you guys are familiar with Avro, you know that Avro has schemas. If you're not familiar with Avro, if you're familiar with any kind of other serialization format that has schemas, it's the same concept. When you've got data, you need to be able to map it to some kind of schema to make sense of it. And in Avro, with Avro objects, you can basically have your schema there. And this schema is going to tell you what is in this object and how to actually work with it and decode it. Not only that, but Avro supports object or schema evolution. And so what that means is, if you're basically changing an Avro object by adding fields, deleting fields, changing certain things in there, if you follow the rules that are available through Avro schema evolution, you will be able to evolve your data in a backward compatible way without breaking it. So we support schema IDs, and what this allows us to do is, if a new version of data comes in, we can identify associated with it, and maintain the fields that are new or thrown. If this was not the case, then what we're going to do is we're going to get fields, we're going to have an old schema, we'll map it against them, but we might lose the two new fields. So this is extremely important. And last but not least, n bytes of data, which is the actual byte array, the user object, the whatever that you're pushing into Kafka is stored there. So I mentioned to you earlier, generic, specific. Generic is cool because you don't have to do anything, you don't have to define a structure, it auto-evolves, it works on its own. Specific is different, but it's potentially more powerful. So with generic, as you can see here, we have like integers, just like maps that store integers, maps that store strings, and all different data types. You're seeing one here for an upgrade, which is why you for an update, sorry, which is why you see an old and a new. And you can probably guess what that means. All the old values when the row was not changed are there, that were ints, and all the new values when the row was changed are there when it comes to ints. So if we look at the specific message format, it's different. It's different because you can directly see the fields that you have. And you have to define this format by hand, essentially. But this gives you more power because it changes the downstream processors from using generic Avro objects, which means essentially like typeless maps, to going to specific Avro objects where you have types and you know exactly what you're dealing with and what fields are available and what aren't. So, alter table we spoke about. I'm not going to go back into that too much, but we can intercept the events and we can essentially see what has changed in the DB, and then, if needed, you can refresh the schema accordingly. Something else that we would like to add in the future is the ability to do an automatic change of the schema without you having to publish the schema into the repository, which is very similar to what Confluent Platform are doing today. So, the final concept here is pipe. The pipe is called mypipe because it basically joins all of these downstream consumers to these producers, and it does so in a configurable fashion. It can do time-based checkpointing and flushing, and it can basically it saves its state. If it dies, if something happens, it can pick up and continue. And it can, as we said, put in files or in MySQL or in Kafka or in CJ or anything. Right here on the screen, I'm going to just show you a very quick config to bringing a pipe up. It's really very simple. It's all in Hokan, which is like TypeScript config. And so basically, you have a schema repository client, which, you know, if you've used Avro, if you've used Confluent Platform, this is all there. You basically define a consumer. The consumer has a source, so this is where it's going to pull from. You define a producer. This is the producer that we're going to use. In this case, we're using something called the std out producer, which basically all it will do is spit it out on the screen. It's not going to pump it anywhere else. We have another one here, which is a generic Katka producer. This is going to use that other generic format to pump the data. So we're going to see the data on the screen. We're going to see the data going into Katka. This is an example of connecting one consumer to multiple producers. So the pipe would look like this, where we would list the consumer, we would list the producer that we want. We're configuring it over here and telling it that it saves its state not in a MySQL binary log position or a repository, just put it in a file. But as you can see, this is how you can change it. This is an example of the modularity that you get. You can write your own class and put it in there, and you can speak with Cassandra or do whatever, and like it works just like that. And you can configure it as well here. And just another quick Katka generic. This is the pipe as well. Goes to localhost and pushes into a Kafka cluster configured by this metadata brokers. In this case, it's just a single one. And as for applications, what can we do with this? We can do cache coherence, we can change logging and auditing, we can do MySQL to HDFS, Cassandra, Spark, all of these fun things that we want to do in real time. And we started integrating with Confluent Schema Registry. We're almost there. So then we'll be able to speak with Kafka Connect. We'll have K-Streams integration directly. And you can also do like real-time notifications, processing anything where you want to deal with the MySQL event stream on the fly. What does it look like? It looks like this. So this is a MySQL server, binary logs. Here's a pipe. Here's another pipe. Here's a third pipe. This pipe is doing a dump, like I said. It selects and pushes them into Kafka. This one is just latching onto the binary log, pushing into Kafka as well. Binary log pushing into Kafka. They all go into Kafka topics. can have a bunch of event consumers doing anything that you want, pushing them into Hadoop, taking it to Cassandra, notifying your users, or building BI dashboards or anything that you want to see, like real-time changing on the screen. And that's it.